Alrighty. What is statistics? Statistics is basically number crunching. That's what statistics is. Any of you ever kept statistics on a football team or something like that? Then that's pretty much what statistics is. This is 13.2. Statistics. A good definition of statistics is obtaining, calculating, and interpreting data. That's a pretty straightforward. Obtaining, calculating, and evaluating data. Think of a gentleman that sits on the or works for the DOT, Department of Transportation, and he's sitting on the side of the road and he's setting up a air hose that goes across the highway, and each time a car runs over it, it's called a traffic counter, and it turns a little clip that turns something in it that keeps up with the little box over here. It keeps up with a traffic count of how many cars go by that hose. And what they have to do is they have to divide it by 2, because how many axles are there usually on a car? 2. They also throw in a contingency for, trailers and trucks and then tractor trailers and trucks, because they have more than 2 axles. So that would be what? Obtaining data. And then you take all that information back to DOT and you unload the box on the computer, and it gives you an Excel spreadsheet of how many, and you take that Excel spreadsheet and you find the mean, median, mode, blah, 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 blah. You find the different aspects of those numbers, and then you have calculation. And then you take those numbers and you evaluate it and you say, well, I think we probably going to need to widen this road and put a red light at the intersection of this road and this road, because the traffic count is getting up toward that number, which desires 4 lanes and what? A traffic light. And that's evaluation of that. So you have these 3 areas in statistics that you pretty much, that's what you're doing. Now, when do you use statistics? Well, you use statistics for anything. You use it for business. You use it in any of the engineering and sciences. We just gave you an example of the engineering. The civil engineer has to design a traffic light, and you just don't stick up a traffic light. You don't do that, because you have to plan the traffic light for the count, not only on the main road, but the count what? On the side road, because you're going to have to put a coil, COIL, I'm sorry, pronounce it however you would like. You got to put a COIL in the secondary roads to trigger the red light, because if you don't, if you have a timed red light, then it'll cut off every 10 seconds, or every minute it'll cut back to red, and then I'm thinking of like Highway 24. And what's that going to do to Highway 24 traffic? It's going to mess it up, because you're stopping for no cars, and that irritates me to death. It's when you come up to a red light, and it is a timed red light, and there is not a car within a mile of that red light. And I run it. I run it because I don't run it like go through it. I stop, and if I don't see any cars within the sight distance of my car, I don't sit there. I'm not going to sit there and stand at the red light when it's no cars. There's something wrong with the red light, huh? Yeah.
I just sat there like 20 years. I was so mad.
And the reason that is because the magnetic COIL did not pick up your car. Huh?
I told him about music. I was blowing the horn, doing everything to let something hear me.
What you should have done is backed up 2 or 3 times and you would have got the light to change. But if there was no cars behind you. Well, you should have, because that's what happened. See, on that one, Dobbins Bridge Road is the actual, or 24 is your actual main fares, because Michelin Boulevard, what was the only reason Michelin Boulevard was put in? Oh, y'all don't know that? My dad was the one that put it in. It was put in for Michelin. That's what it was put in for. They had always talked about putting in a bypass in this area. And it was on the drawing board for about 15 years. And it was initially supposed to go right by the airport. And they were going to use that road by the airport to do it. But when Michelin came in, Michelin bought that property over here, so it kind of moved the bypass this way a little bit. And it was going that way. It was going down that way toward that, what's it called? It was called Airport Road, but it's down there where New Pond Road is and all that down there. But anyway, they put Michelin Boulevard in for Michelin. And that's technically a secondary road compared to Dobbins Bridge or 24. So that's why when you came down Michelin, you had to wait because you didn't hit the magnetic strip. Now, if it had been time, you would have been all right because you just would have waited 30 seconds, 45 seconds, and it would have flipped. But they don't make timed anymore unless you're in the big city, or a big city or a town, to where you have 3 or 4 red lights, and each one of them comes on like a second after the next one comes on. Those are timed red lights. And that's why a civil engineer has to come in and do that, depending on how many red lights are on down the road, what the traffic count is on 24 versus, and it takes a lot to put up, now it doesn't to actually physically put it up, because you just go out there, stretch 2 poles and put it, but the engineer has to come in and look at the traffic count. How about health ed? Any of your health industries, okay? Especially babies, okay? They want to know the mortality rates. They want to know the increase or decrease, the males versus females, the moon being full versus the moon not being full, whatever the case may be. And there are all kinds of tales about working on the pediatric floor. And, okay, the moon's full, we're going to have 15 babies by the end of the week. And they'll tell you stories about stuff like that. And it's true. And I don't say it's not true at all. I think the moon has a lot to do with it. Dang old moon can dang old move waves of water. It can dang old influence dang old pregnancy. All right, so business, engineering, health, any business you're in. I don't care, what business you're in. You are going to use some kind of probability and statistics. And just think about it. Have you ever got on a long road? Like I use Wild Hog Road for example. Wild Hog Road, here's double bridges, 24, double bridges, Highway 24. And then you get to Garrett's and Portland Marina right there, 24. And Wild Hog Road goes to Pendleton. And it's about, I think it takes me 16 minutes to get from Anderson to Pendleton. Okay, when I go Wild Hog Road. And you get to the end of Wild Hog Road, which way can you go? Right or left? Hubert, that's right, class. And if you go left, you go to Pendleton. And if you go right, you go back toward the Anderson Michelin plant, right there, Smoking Pig plant, all that is. So that's Anderson right there. So you're on the road and you think you don't use probability every day. Let's say that you're on this road, and I'd say it's anywhere from 15 to 20 miles long. It's a long road, all right? And there's no curves on it. It's just pretty much straight. And you get on this road, and it's about 7:45 a.m. and you crossing the double bridges. And guess what time you have to be at Pendleton? 8 a.m. You got an 8 o'clock class. All right, you get in that right lane and you turn. And here you are. And bam! Who gets in front of you? The blue-haired little old ladies club. All right? All right, so you get behind that little blue-haired old lady. And she goes, how fast does she go down 180, down the Wild Hog Road? Well, the speed limit is 45. She goes 43 miles an hour all the way down Wild Hog Road. By the time you get to the end of Wild Hog Road, you are cursing that little blue-haired old lady because it's 10 after 8 by now, and you are mad. All right, you get about right here, which is Pendleton High School. You get about right there, and you start thinking to yourself, okay, I got to get up this red light, and I'm going to turn left. And you think to yourself, oh crap, that woman in front of me is going to turn left. I know it just as sure as the world. And you get up to that place right about here, right here where the turn left lane is to turn whatever. You know, you get right there, and you get up right about right here, and you say, I'm going to turn my blinker on. And right after you turn your blinker on, guess what? Grandma turns on her left blinker, and she gets in this lane, and she creeps in this lane like this, and she gets up here. Of course, the light, by the time she gets up here, you were back here. What color was the light? It was green. Now that she's taking her sweet time, what color is it? But you predicted that she would what? You would have predicted. No, you can't pass on Wild Hog Road. You get head-on collision. There's all kind of traffic coming down. The whole point is, you use probability and statistics every day. You just don't know. Now, a lot of people say, well, where's the math behind that? How many times have you gotten behind that little blue-haired old lady or that little blue-haired old man, and he's going 35 and 55 zone? How many times have you done that? Not today. How many times since you've been driving have you got behind somebody that drives 10 miles or less, or more, less than the speed limit? Okay, so how much mathematics have you got to back this up? You said thousands of times. Countless. You got a large number. Because all of us do remember. We remember this. Why do we remember this? Because it pisses us off so much. I know, I'm just using this. All right, the whole point is, no matter if it's driving down the road, you use this stuff. Now, you don't think about it, but just like you said, countless. You've got countless evidence or countless scenarios where you have gotten behind somebody going 35 miles an hour, and you can predict pretty much they're going to turn the same direction you're turning because you've gotten behind them before. Now, then very rarely, somebody that gets on Wild Hog Road in Anderson is usually going to Pendleton. They're not going to Anderson because that would be a circle. All right? So most of the time they're going to be turning left because they're going to Pendleton. All right. I'll give you another instance of just out of the blue probability and statistics. I got a pasture right here. And this pasture is about 20 acres. And I got some cows in this pasture over here. It's about another 20-acre pasture. And this is 20 acres plus or minus, and this is 20 acres plus or minus. And I got a gate right here that opens up. And I open that gate. Well, I'm just making a gate here. I'm going to put a gate. I don't know why that's doing that, but I think we can. Okay, go away. I'm just going to put a gate that opens like that. There we go, that way. And I got another gate. I got another pasture here. I got a pasture here and a pasture over here. I got several pastures. And I got a gate right here that falls down all the time. I'm going to just put a dotted gate right there, meaning it falls down all the time. And now I've got a holding pen over here. This is my holding pen. I got my head gate, where I vaccinate all my cats. If you're on a farm, that's what you call it. I don't care if you got hogs, I don't care if you got pigs, I don't care if you got sheep. When you get them up somewhere to work with them or vaccinate them, it's called holding pen. All right. Now, there's another gate down here to a pasture. And here's my pasture, and I'm going to put a gate right here. And I forget to open this gate, and I forget to close it. And that one falls down. I get my cows up, and my goal is to get them in this gate right here. And y'all's like, what in the world is he talking about? Here's my gate that I want them at. I'll color it red. And I'll open it. I'm going to open it. So I open it, and I'll color it red, and it opens up like that. Now you're going to leave, my cow story, you're going to leave.
I gotta pick up my niece.
Oh, family comes after man. All right. So, anyway, I get my cows in, and here they come. They running. I got about 50 head coming down through here. And they come down to this gate. My question is, which gate do you think they're going to go to? They're going to this gate right here. They're going to shoot for this gate. Why?
Because it's open.
Because they read your mind? This one's open.
That's the holding people. They know.
Yeah.
They're going to go out there.
They know. And you can predict. I will not get a cow up. I will not get them up unless this gate is wired where it won't fall down. Because here's the other probability. What's going to happen if I close this gate, and I open this gate, and I don't wire this gate? That one's going to fall down as soon as they walk into this gate right here. It will happen every single time. And the wind, like if it was closed, and this is one of those gates that stays closed unless the wind blows. It will wind. The wind will blow as soon as the cows come in here. The wind will blow, and this thing will open up, and it's like a radar, and these cows will go boop. They'll go right to it every single time. Now, again, some of y'all are like, what does this have to do with math? This is probability. This is and the reason this ain't math. Yes, it is, because I've gotten up cows all my life, and I can tell you if there is something in a pasture that's going to happen, like a gate falling down or one of them opening by accident, it's going to happen as soon as they walk into this gate right here, and you're wanting them to go right here. One of these, they're going to go toward, or they're going to run to this one, and one of them's going to hit it, and it's going to what? It's going to fall down. So from now, I've learned, and I will go, and I don't care how long it'll take, I'll close that gate, and I will wire it. I will wire it shut. And I will wire this one on both ends where it won't fall down. And what they will do then is they'll go to this one, and then they'll see it's closed, and they'll turn around and do what? They'll go to this one, and once they get those two out of the way, then they know, oh well, I guess we got to go in here. And that's what they'll do. I'm telling you, every single time they'll do it. But again, you have the math to back it up. If you've never dealt with cows before, you go out there and stand and have no idea which one they go to, because you don't have the math or you don't have the experience to back it up. And that's what probability is taking this right here, taking the statistics and turning it into probability and turning it into thinking, okay, which way is that little blue-haired lady going to turn? She's going to turn left, I guarantee you. That's where the probability and the statistics work with each other. And this is obtaining, calculating, and evaluating data. Now, evaluating data can move over into probability, and we'll talk about probability. I know it comes before, and I don't agree with that. I don't think you can have probability until you have statistics. So that's why I'm teaching chapter 13 first. All right. Now, the main thing about statistics that you need to know is there are two things that are very important in statistics. Two things that are very important in statistics. And those two things are, and I'm going to put them in red, meaning that you need to know, you need to highlight them, is the mean and the standard deviation. And you just put stand dev. Okay, that's standard deviation. This right here, mean, is basically what they call in statistics as the center. And then the standard deviation gives us a field. I call it a field. In other words, a limit, a lower limit, and an upper limit to say if something is normal or unusual. Now, we need to work on this in the next week to get you, or the next week and a half, I don't know, isn't it December when the end of the semester exams, 2 through the 5th? Yeah. So that means we've got a whole month to go over. So we got 4 classes, and for each 2 weeks. So we got 3 more classes talking about how to get this, and then 3 more classes, 3 or 4 more classes talking about how to do probability. So now most of y'all know how to do probability. How to do statistics, because all of us, including myself, going through school, what have we always figured out? Test average. And what do? You add them all up and do what? Divide by how many you did. So if you took 3 tests and made an 80, you got an 80 average, because 240 divided by 3 is 80. So that's how you found how to do that. So there's no problem there. You know how to do that. What else is it? Well, there's some little odds and ends that you need to know. The mean is the summation of x over n. That's what you did. You add them all up and what? Divide by the number. Now that's what that means. This is a pinky way. Hold your pinky up. It's called summation. It's the Greek letter sigma. Sigma is actually, it looks like this. That's sigma. And it means whatever numbers you got, add them all up. That's what it means. It's called summation. And if you want your average in a data-driven table, data means like 3 test scores, data. Then you take all the test scores and what do you do with them? Add them up and divide by what? The number of tests. All right, so y'all know how to do that. Then there's the the median. Median is a 25-cent word for middle. If the number of test scores, let's say test scores, is odd, then you just pick the middle. You count down. You got to put them in order, and that's true whenever, and let's write that down. Whenever you're dealing with statistics, the first thing you do is put your data what? You know it? Yeah. So that's a little star. Data in order. Okay, that's a given. The median is the middle. If you have an odd n, then you just count to the middle. If you have an even n, anybody know what you do? You add the 2 in the middle up and divide by 2. Add 2 in the middle and divide by 2. And we'll go through and do that. What is the mode? Well, mode, just remember most. They both have what? M-O in it. Mode and most. It's the one that shows up the most. Number that shows up the most. So we've got the mean, median, mode, range, is your highest minus the what? Lowest. And then the mid-range. In the mid-range, I don't have any room, so I'll make it a little bit smaller if I can. Really? Okay, mid-range is like midpoint. I'm going to put midpoint because some of you may remember how to find the midpoint of a line. It's your highest minus that's your highest plus your lowest divided by 2. And that's your mid-range. Now all of these, what do these, most of these, okay, this one, and this one, what do they focus on? What do all three of those have in common? That's not rhetorical, I'm asking y'all, that means give me an answer. What do they all have in common? Or what do they all focus around? Well, yeah, but let's look at, you're right, that's not what I'm looking for. Let's go back to, where did I write down 2 important things? Okay. What did I say the mean represented? All right, look at mean, median, and mid-range. What do they focus around? Center. Thank you. They all focus around the middle or the center. What do you mean? Well, what does this have right there? Middle. And what does this have? Midpoint. So what do all they have in common? All of them have center in common. Center is very important in statistics and probability, or especially statistics. What's the first thing that a college teacher will write on the board when they're handing out tests? After they've graded. What is the first thing they write down on the board? Does anybody know? The test what? Or the class what? The class average. Because they want the students to know where they stack up against what? The rest of the class. Because that's important. Because if you've taken a, let's say you took a psychology test and you made a 52. And you freak out and go hammy on me, start acting like hammy and start bouncing around. And the class average is 60. Does it help you to know that you still made a 52, or does it lessen the blow a little bit? It lessens the blow to know that you scored a 52, and the highest, the highest somebody could have scored is probably an 80 because class average is around 60. All right? So it does help you, and it does let you know that you are around where most of the class is with that 52. Doesn't make it better as far as calculating grade, but it tells the teacher that if her class average is 60, or his or her class average is 60, that either the class is lazy, one of 3 things. What are they? The class is lazy, or what? The teacher sucks, or the test is what? Invalid. meaning that it's not covering what the teacher has covered and you wrote down in your notes. One of those three things. Now, if the class average is 75 or 80, then that means that everything's doing pretty good. Either the class is working very hard, the teacher is decent, and the test represents what the teacher has gone over. All right. So even in a classroom, you don't have to have statistics. Even in a classroom, when you get that first test back, statistics is important there because it tells you where you are in relation to the rest of the class. And that's these guys right here. We're going to go over that several times, so you don't have to worry about being able to do it. The standard deviation, you didn't write it up there. Well, we're going to wait on the standard deviation and the variance. We're going to wait on that because that's next. It goes the mean, median, mode, range, mid-range, variance, standard deviation. That's the whole list. But we will cover the variance and standard deviation, which is pretty much the same number. One, you get the number. The other one, you get the number and you take the square root of it. So the variance is the square of the standard deviation. The standard deviation is the square root of the variance. They're both interchangeable. So it's not like you have to learn two different formulas. You learn one formula, and you get your number for your variance, and you take the square root of that variance, and you got your standard deviation. So we're only going to learn basically one formula. Okay? So that's the kind of an introduction to statistics. Let's see what they give us. They're talking about misuse of statistics. Yeah, I can show you a lot of misuse of statistics, especially when they put graphs in the paper. Let me give you a misuse of statistics. I went across the United States and I surveyed people, and I found out that the next president is going to be blank. All right? I don't know. You can fill in whatever you want to. And I go through and I do the research and I tell you that I went across the United States. What I didn't tell you is that I surveyed people in South Carolina, Georgia, Mississippi, Alabama, Louisiana, and Texas, and then I went to California and surveyed people in California. Did I cover the United States? Did I go across the United States? Yes or no? Yes, I did. Physically, did I go across the United States? All right. Did I get a sample out of each and every state? No. And that's one way that statistics can be misused. I can get on TV and I can say, well, I can tell you right now the next president's going to be blank because I did a survey across the United States and I found out this, this, and this. Well, I went through, what's wrong with going through the South to Texas and then to California? Why is that going to be biased? Huh? Why? She's right. Most of the states that I said, well, I didn't include North Carolina because they don't count anymore. No, I'm just kidding. In South Carolina through Texas, what's that called? It's the Bible. It's called the Bible Belt. But what is it called geographically? The deep what? The deep South. The deep South is traditionally conservative. I don't want to say Republican because there's a lot of Democrats that are very conservative because Democrats used to be very conservative until it flip-flopped. But that's why I use conservative, because you got a lot of Democrats that live in the South that are the old Democrats that they still believe in hitting somebody upside the head when they go to sleep in church. All right? They're very conservative. But, you know, and where would your liberal, most of your liberal are California and New York and Chicago. Yeah, those are some of your more liberal states. But I said I went across America. Yeah, I went across America. I physically went across America, but I did not pull statistics from across America. I pulled it from 5 or 6 conservative states and 1 liberal state. So people can misuse statistics. So when you see a survey on a news show, you might want to find out where they did their research. Because half the time, or not half the time, some of the time, people do misuse statistics to try to get their agenda across. Okay, I'm not going to pull up a lot of that on the test. I'll let you look at a picture like this, and you tell me if it is a, you know, if it's bad or good as far as, is it a good indicator? I don't think so. Why do I not think this is a good graphic? Why is it not a good graphic? That's not rhetorical. I'm asking y'all for some input. Which one's bigger? The one on the right or the one on the left? Thank you. Thank you so much for that interaction. You mean y'all can't tell me which one's bigger? One person? Really? Now what does that have to do with it? We'll look at them. One on the right is bigger. Well, they are two different sizes. That's very observant. Yeah, thank you. No, but look at the numbers. You can't see?
No.
I think you need some glasses. Somebody give him a glass bottle so he can look through the...
It's like, he's saying bad.
Okay, how's that?
Better.
Well, I'm sorry. Yeah, it does, but look at the percentages. I mean, the percentages look like they're smaller, yes. But what do they look like as far as the circle? They make the right one too big that it looks like the 52% is almost equal to the what? To the 71%, but it's not, because if you was to put the two side by side the same size, the 71% would look much what? Bigger than the 52%. And they don't want you to see that. They want you to think the one side is smaller. And it's like an optical illusion, but they will do that. Another thing is done quite frequently in media. They'll put a problem like this. I don't know if that one's one or not. I'm adding it up in my head. Yeah. What's wrong with this one? I'm sorry, what? It doesn't equal up to 100%. And they will put these up on TV and in the newspaper. They'll put these up all day long, and they don't equal 100%. Just like that question I give y'all for 10 points or 5 points on the test. What is it? How does your homework, test, and final exam weighted?
30, 30, 30.
And people put 30, 30, 30. 30, 30, 30 only equals 90. Yeah, I play football. It's got to equal 100. Just like that one. So this one is incorrect because it doesn't equal 100. And you think people don't get that wrong. They get it wrong on that test. They'll get it wrong on this if I put that on the test. Somebody will say there ain't nothing wrong with it. Whatever you say. Frequency distributions. That's a big word. Let's talk about frequency distribution. You know what a frequency distribution actually is? A lot of people will say no. Frequency distribution is a table. That's all it is. Let me show you what I'm talking about. Let's say that I decide to count how many people in here are blonde, brunettes, or redheads. Okay? We don't have any redheads, so that's going to kind of narrow it down. And I say, put a table, and I put color over here, and I put head count over here. Blondes, brunettes, redheads. One blonde, and 1, 2, 3, 4, 5, I'll count myself, 6. Redheads, none. And other, 1. Okay? All right? So, what do I have? This is called a frequency distribution. A frequency distribution is nothing but a what? Head count. Is a head count with classes. Head count with classes. And it's usually in a table form with the classes on the left and the number on the right. Now you can impress your friends by using the word frequency distribution wherever there's a head count. Now, in statistics, you can use both. And you can find the mean and the standard deviation of both. This one's a little bit more complicated. Well, one, we don't have numeric classes over here, so you can't do it with this one. But like ages, 20 to 24, 25 to 29, 30 to 34, you know, that type you can. So there's two types of information in statistics. Two types of statistical information. And I'll just put them in two columns. On one side, I call it the data-driven. Okay? That's not a mathematical term, that's a Hubertism term. In other words, test scores. What else can we do? Age. The average age of the class. I could do the average shoe size. I could do weight of each, the average weight of the class. So what I mean data driven. In other words, test scores. Here's test scores. 78 plus 90 plus 82 plus 95. There's 4 test scores, and I can take those 4 test scores and give you the mean and the what? Standard deviation. Age. Let's say out of this class we've got 18, 18, 19, 22, 48, and 56. I have no idea. That's just 6. In other words, if I wanted to find the mean and the standard deviation of these ages, then I just do it, add them up, divide by 6, and find the standard deviation, and then we could work with that. Shoe size. Let's say we got 4 people in class. One wears a 10.5, the other one wears an 8, the other one wears a 6, the other one wears an 11. Then I average those up, divide by 4, and I can find my mean and standard deviation. Weight. Let's say we have all the women weigh 105 pounds, so we'll just say that. And then we got 150, 200, and then I'll add myself at 250. So you got 4. You add those 4 up and divide by 4. Everybody get the gist of data-driven? You just add them up, divide by the number, and and you've been doing that forever. Then the other is frequency distribution. And I'm not going to put a bunch of examples, but let's just do age and number. 20 to 24 is 5. 25 to 29 is 2. 30 to 34 is 1. And 35 to 39 is 2. All right, I'll do that one, and I'll do grades. That's age, grade, and number. 80 to 89, oops, sorry. 90 to 100 is 4. 80 to 89 is 5. 70 to 79 is 6. And 60 to 69 is 2. All right, both of these are frequency distributions. And I can find the mean and the standard deviation for both. So here, I can find the mean and the standard deviation. And here, I can find the mean and the standard deviation. And that's basically what statistics is with both of these, finding the mean and the standard deviation. I don't know if we're going to find the mean and the standard deviation in this book, in this course. I know we do it in 120, and some of you might come back and take 120 at a later date. But most of you know how to do this. I don't think we'll get that far with this. I think they just want you to know the definition of a frequency distribution, which is a table showing the class and what? The head count. And they talk about that in the book. For those of you that have a book, they talk about it on page 783. So while you're looking at this, look at number 1 right there. I'm going to blow it up for all those people that have a hard time seeing on the second row. Now, I want you to make a frequency distribution. The following data. Now, they want you, now they haven't given you the number of classes, but you don't need the number of classes. It says the number of children per family is recorded for 64 families surveyed. 64. So that means 8 across and 8 down. How many couples had 0? How many couples had 1? How many couples had 3? How many couples had 4? Go ahead and look at this chart. Oh, I got to bring it up. And I want you to form a frequency distribution based on that chart. This data. I'll be right back. Finish writing it down. So, how many of the, well, let's just write it. Bring it down. Now that y'all wrote it down. So I'm going to draw me a chart, and the number of babies and how many families had that number of babies. So how many had 0 babies? Well, 8. 1, 2, 3, 4, 5, 6, 7, 8. How many had at least one baby? 8, 9, 10, 11. There you go. And how many had 2? Well, there's 8. And there's what? 13. And how many is there? 5. That's how many? 18? So 2 had 18. 3. How many 3? Well, let's see. Here's 8 right here. 11? 11, yeah. 4. Let's see. 5. Why do you think it's decreasing? Mama don't want to have 15 kids.
6.
Huh? 6. And 5. 5 is 4. And so on. 6. 7. 1. And 8. 2. And 9. Why do you think it decreased? Because, like I said, you gotta pass some things through the boss before you. I don't think a lot of women want to have 9 or 10 kids. I don't know if I would. I don't think I can handle 2. I got 2 and I can't handle 2. So I think Mama might have something to do with that. That's why it's decreasing. Because she's the one, huh? Yeah. They need to figure out where them things are coming from. Huh? What? Tell me about it. That's what gets me. Y'all ever seen these shows where people have like 19 kids? What do they do for a living? Most of the time they don't have a job. How do they do that? It's the Bush's fault. Yeah. Maybe they just put in for government assistance for 19 kids, and that's just, you can make, $180,000 with 19 kids. And there's classes. Okay, now, what are the classes on the left called when you have a class? That's the lower class limit. What's the classes on the right called? Be careful here. This is some real hard stuff. Upper class limit. Because it's the upper side, lower side. Yeah. How do you get one? Well, they give you the, I don't know if this book tells you how to find the upper class limit and lower class limit, but I'm not looking at that. I'm looking for one. Okay, this one, they say the following separate set of data represents the family income, blah, 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 of 15 randomly selected families. Well, what is n in this problem? What's n, the letter n? What would somebody tell me what n is equal to? 15. N is always the population. You need to write that down. In this class right now, what is n? Well, 1, 2, 3, 4, 5, 6, 7. N is what? 7. And you need to write that down. Whenever you see the letter n in statistics, that means that you need to count up how many is in the population. How many is in the population here? $15. Thank you, sir. Appreciate the interaction. A lot of people had to really take time and count them. All right. Now, what do they say? Construct a frequency distribution with the first class of what? 31.5 to 37.6, Hubert. Okay. Now, think about how many classes you need. What is significant about the number 15? It's also divisible by what? So you can either have 3 classes or you can have 5 classes. Which one are you going to pick? Most of the time, you usually have 4 or more classes. Usually. So I would go with the 5. So the first one is going to be 31.5 to 37.6. What comes after 37.6? 37.7. That's right, class. And then 37.7. What is the difference? Somebody tell me what the difference is between 31.5 and 37.6. Take your calculator and divide subtract 37.6. 35, I can't talk. 31.5 from 37.6. What'd you say? 6.1? It's actually 6 because you got to include 31.5 and 37.6. So the class width is 6. So the next one, 31.5, is going to be 31.7. And then 37.6 is going to be, class width of 5 would be 42.6. And that's how you do it. And they're going to show you that down here. And they show you right here. The first class goes from 30. I'm looking for the second one. There it goes. See right here, what I asked you. I asked y'all what came after 37.6. And what'd y'all say? Nothing. 37.7. It comes next. So that starts your first class. The class width of the first class is 6.2. I just rounded to 6 so I could add. But you got 6.2. That's right. So add 6.2 to 37.9, 37.7. What do you get? 43.8. And that's your upper class. Now you need to highlight that on page 786. That's how you find the bottom of 786. That's how you find your classes. So let's do that on the board. What did you say the first one was? I'm going to get 5 class limits. Now, I don't know. It might not have said 5. It might have said 3. I don't know. But you know that n is equal to 15. Therefore, the class size is either 3 or the class size is either 5, because 3 times 5 is what? 15. You couldn't say, well, I'm going to make it 4 classes. Well, the problem with 4 classes is what? 4 doesn't go into 15 that well. But it may end up that the information will only let us have 3 classes. In other words, when we get to that last number, it may be just in the 3rd class. So we only need 3 classes. So let's see what happens. I'm going to put classes over here and number over there. And my first one, what did they say the first one was? to what? $37.6. And, well, we subtracted that a while ago in our class width, and this is how you find the class width. The class width is equal to 37.6 minus 31.7. You said that was equal to what? 6.2? Is that what you said? So now, what's my next spot right here? 37 point what? 7. And then I'm going to add 6.2 to that. What does that give me? 34.3? I have no idea. Y'all need to help me. 44.3, sorry. Is that right? Yeah, that's right, Hubert. I added it up with my calculator. Thank you. Appreciate the class. 37.6 plus 6.2. 43.9. Dang, I'm way off. I don't know what I did on that one. 43.9. All right, what comes after 43.9? 44. Sorry. All right, now I might want to put this one in the calculator. 44 plus 6.2 is thank you. I appreciate the interaction. What comes out of 50.2? 50.3, and that'll give us 56 point what? 5? And then 56.6 plus 6.2 is dang old 62 point what? 8? Now, somebody look at your information that they gave you. What's the incomes? Let's look. 31.7 to 37.6. Let's look at our information. 31.5 to 37.6. How many we got? Well, I don't know, Hubert. There's one right there. Yeah, it's class. There's one. And then let's to 37.6. Anything below 37.6, there's another one right there. Anything else? Why? Well, yeah, you can do that. I'm just looking, yeah. How many? 2. So what's the head count on 2? I mean on those 2. 2. So there's 2 right there. So we're going to go ahead and go to our handy dandy and put a 2 right here. 37.7 to 43.9. To 43.9. How many? 3. I don't know what I'm doing. Thank you. 3. 44 to 50. 44 to 50. Now 50 point what? Huh? How many? Dang old 5. 50.3 to 56.5. How many? 4. And how many in the last one? 1. How do you check to make sure you hadn't made a mistake? Add all these up and you should get what? 15. 15. Add them all up. 2, that's 20. And that's what? 5, 6, 7, 8, 9, 10. And there's 2, there's 15. All right. Y'all got to get out of here because y'all are like packing up, so I guess that means y'all are done.